Okay, so solving two-step inequalities. It says solve the inequality and graph your solution. Well, I would read this as 3y plus 1 is greater than 13. Pardon my cough, excuse me. All right, so draw a line down the middle. Tell students to get rid of the constant first. We'll deal with the coefficient and the variable next, but first let's get rid of that plus 1. So we're going to add -1 to both sides, which leads us to 3y is greater than 12. Okay, so that's not bad. I'm closer, but I've got 3 y's. I only want to get down to 1. So divide both sides by 3. That will leave me with 1y here is greater than 4, right? Because 12 divided by 3 is 4. So you can put the 1 there, you can put the little dot there, but most people just write it this way, actually. They write it as y is greater than 4. Okay, and then to graph your solution, it would look like this. I'm going to put 4 in the middle, 5, 6, 3, 2. Okay, so greater than 4 is everything that's over here. And it's not or equal to 4, so I'm not going to color the little circle in. It's just y is greater than 4 like that. You could have a situation like this. Excuse me. It says Jason has to buy a whiteboard for $80 and markers that are $3 each. He has to stay under $125. So write an inequality to model this situation. All right. So the whiteboard is $80 and he only has to pay that once. But he gets to buy a whole bunch of markers. Now those markers are $3 each, and I'm going to multiply that times m. M is however many markers you can get. Right now I'm not really sure what number that is. And I do know that I need to be under $125. Now, can I equal $125? It says he has to stay under $125. So no, I can't equal $125. I can do $124.99. So here we go. I'm going to subtract the cost of the whiteboard from both sides. Also, the way I teach it is I add -80 to both sides. But a lot of people will just subtract 80 from both sides. As long as you get the problem right, I almost don't care what you do. So 125 minus 80 should get you down to 45. Okay, so that means he's got $45 left to spend on markers, and markers are $3 a piece. So $3 times m, and he has to stay under $45. Okay, so divide both sides by 3. And that means he can buy less than 15 markers. So m, the number of markers, is less than 15. If he buys that 15th marker, that will get him to exactly $125, and the instructions in the budget says he has to be under $125. So m is less than 15. So to graph the solution on a number line would look like this. There's 15, 16, 17, 14, 13, like so. Put a circle around the 15. I have to be less than 15, so that's this way. So that means that 13 markers are okay, 14 markers are okay, 12 markers are okay. I just can't hit that 15. Now, of course, this is not totally precise, because this also implies that 14.5 markers are okay, and they're like 13.25 markers, and 13.5 and 13.75 markers are okay. And students will iron out some of the wrinkles on those in 8th grade. I mean, if you follow this number down forever and ever, like you would get to -1 million eventually, right? Because you get down to 0 and the negative numbers. And obviously -1 million markers doesn't seem to make sense at all. And as students get into older grades, you'll clean that up. They'll put boundaries on both sides. But for right now, let's just say m is less than 15. Done.